So today we are going to talk about electronegativity, which is the relative electron attracting tendency of an atom for a shared pair of electrons in a covalently bonded compound. So, by breaking this definition, let us understand what electronegativity means. So, there is something known as electron affinity. Affinity, in the sense how much an atom wants more of electrons in it. In a covalently bonded compound like water, we have oxygen. It bonds with a hydrogen. Yeah, so this is hydrogen, and a stable compound is formed called H2O. In this, if you would notice, oxygen is more electronegative. Oxygen is, we'll see why it is, but let's just understand it is more electronegative than hydrogen. So there are more chances that the electrons, they're nearer to oxygen, because oxygen is like more powerful in terms of holding the electrons compared to hydrogen. It's more electronegative. So in this covalently bonded compound, relative to hydrogen, oxygen has more of electron attracting tendency. It tends to attract more electrons for a shared pair of electrons, that is these four electrons are a shared pair in a covalently bonded compound or molecule. So as you go from the left to the right of the periodic table, that is along the periods of the periodic table, the electronegativity, let's refer to it as En throughout the video, keeps on increasing, while as you go down the groups of the periodic table, the electronegativity decreases. The reason, so we had studied in the previous videos that as you go from the left to the right, the atomic size keeps on decreasing because of the increase in the effective nuclear charge. And also, if you would notice, the valence electrons are quite a lot, these top right elements. So the valence electrons are quite a lot. Let's take an example of chlorine, which has got the atomic number 17, and this is its electronic configuration. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 7 more electrons left. So chlorine has got 7 electrons. To get the octet rule, it can either lose all of these 7, be left with 2 orbitals, or it can gain one more electron, right? So gain one more, that is gain a negative charge of 1. Okay, by gaining, it's gaining a negative charge of 1 since it has more of electrons. So that is more convenient and energy efficient for chlorine. So it would prefer to be Cl minus. So it's you can see this minus symbol, negative. So it is quite electronegative. So it wants electrons, and it as soon as it comes across another atom which from which it can easily gain an electron, chlorine has that power, that capacity to gain that electron quite swiftly, like efficiently, and so it's more electronegative, and it has the tendency to hold and hog on more electrons. While if you look at another of the atom or the elements of, that is sodium, which has got 11 atomic number. So I've got my sodium atom, and the outermost one has got just 1 electron. So this one would rather give. Chlorine was rather taking, but sodium is rather giving the electron because it's not efficient for it to gain more electrons. So it has a valency of +1. Okay, and it gains after it loses that electron, it becomes more of positively charged, and this is how you would write the sodium ion. So sodium ion is electropositive. Yeah, this is something called electropositivity, which is quite the opposite of electronegativity. And just a note to be something to be noted, that this chlorine is a metal, and metals are electropositive. They prefer losing their electrons, and that is why one of the reasons why they conduct electricity, while you have got this um, mm, chlorine, which is electronegative, which prefers gaining an electron to attain stability. We have seen that atomic size, if it is decreasing, which is much happening over here, this region, it's got more of the atomic size. Let's not consider these. Okay, so we shouldn't consider the noble metals. They are not concerned about these things. Let's leave this chain over here. These noble, not noble gases, I'm sorry. So what these are: oxygen, fluorine, sulfur, chlorine. These are the most electronegative elements of the periodic table, and the ones right here, cesium, barium, etc., these are the least electronegative elements of the periodic table. So as you can see, as I'm going from this bottom left to the top right of the periodic table, my electronegativity is increasing, while as we saw in the earlier videos, that the atomic radius is decreasing. So it's kind of inversely related to the atomic radius, the electronegativity. So as in when the electron negativity is increasing, that is because the atomic radius is decreasing, and that is because of the effective nuclear charge. So you would see, if an atom has got more effective nuclear charge, that means it can hold more electrons, right? So it's able to hold more electrons, so it is ready to gain another one or another group of electron. But if it's having less of effective nuclear charge, then it prefers rather giving its electron to have that stable energy configuration. And if you look at sulfur, I had underlined it as one of the most electronegative elements. So it's got 2,8,6. So it would prefer to gain 2 more electrons and become S2 minus, that is the ion of sulfur.